Okay, I'm dicking around my airplane motor some more today a little bit in my off time. So we got this thing strung up over here out of the way a little bit. So this is the twin cam case, and this is the cylinder for the big one, and these are the different cases here we got. So you got the Buell XB case, and we got the I think this is a 07 or 06 Sportster case or something like 8, something like that. We got an Ironhead Sportster case here, 78 I think. And then we got a 45 flathead case, which are pretty much all the same from 37 to 72. They're all basically the same damn thing. So we got that on there. So things we found out was that the height of our cases vary a little bit. So the Ironhead here is the lowest one. So you go from the center of your main bearing up to your deck height, which is over here. And we can measure that. You get about 4 inches or 5 inches there. And the Ironhead Sportster and the 45 are the same height. When you go to your buell motor over here, you go from the deck height to your center of your case. You're about 4.5 inches or 5.5 inches, about a half inch more. When you're on your other case here, deck height should be the same as gasket surface, and it's about 5.5 inches like the buell. Same thing. So those are all the same. The twin cam, when you do that, about halfway, we're flush up here, we're 6-inch deck height. And I'm thinking maybe I gotta go an inch higher than this one. So that means we're gonna have to go 1.5 inches more than these two. And this one over here would be 2 inches taller. So that means you have to build it up 2 inches. Quite a bit. The other thing I was looking at was the height of between the cam bearing and the cam cover gasket surface. So these are about 1 7/8 inches roughly here. And these ones over here being Sportster parts, they're all about the same. So they're all right there at the 1 7/8 number. Because this is all the same from basically 1932. They did this pattern and they used it all the way up to the current. So this one's actually a 1942 case, military case, but they're all the same. Now in 37 they made the hole bigger for the shaft, but other than that it's the same. The gears are all the same. The centerline dimension from the main shaft centerline to your gear, it's all the same stuff. The gears are all the same. So they never change anything. Even with this rubber mounted stuff like this, they kept the same bearing, shafts, locations, and everything. They didn't change anything. So basically 1932 to 2022, 90 years, it's the same parts, pretty much. So, which is nice. But there's difference on the location where your lifters are at. So these motors are on center, which means when you go down the lifter, your lifter's basically on center. It's just a little bit off, but it's pretty damn close. So they're actually slightly forward by about 1/16 of an inch or so. So when you do this motor, you can see a little bit better. You lay it in there, right on the bottom, and you can see it ain't even 60, it's about 30-second off. Just a little bit off. Exhaust, same thing. See, just barely over a little bit. Versus your Ironhead motors and your 45 motors, they are off center. See how they're off center? That one's way over here, and this one here is way over here on this one. So see, they're like that. So they're off center. So these are off center cams, and these are on center cams. The 4-speed, all your 4-speed bikes are off center, all your 5-speed bikes are on center. So when you're playing with different cam lobes on your cams, you got to know that because it makes a difference in timing, obviously. So you're dicking around with that. The other thing we found out is the lifter block, or the lifter spacing, which is the distance between here, is 1 3/4 inch on these bikes, these late bikes. And when you get onto your Ironhead motor, it's 2 1/4 inches. roughly on center. And when you measure the airplane motor right here, it's 2 inch on center. Both here and down here. 2 inch. See? So this is a parallel motor, it's all straight. It's 2 inches on center. These are 1 3/4, and that's 2 1/4. So the airplane motor is right in between. The other thing we had a problem was that these here, obviously the push rods are straight up. Here, the lifters are straight, perpendicular to your cylinder decks. This one is the same also. And iron heads are not. These pieces of wood are the same dimension. So when you line these things up, see how this one comes straight out like that? It's basically not quite perpendicular, pretty damn close. But you come off of this one here, and you notice it's not. The gap change. So when you put the cylinder on here for the airplane, and you move it back to make room for the 2 cylinders, the higher you go, the worse the intake is not where it belongs. Because these are supposed to be, this direction like this works better. Goes like that. They sit right in here like that, and they're 2 inches. This is 2 inches across right here. Okay, there's your 2 inches right there. These are parallel with each other. So these are too narrow, and that one splays out real bad. What I did find out was the 45 flathead bike, which takes these cylinders down here, are parallel. They come straight out because the 45 cylinder has valves right there. Which one? The rear one? There's the rear cylinder right on top. These valves are 2 inches apart, same as the airplane motor. See, 2 inches, 2 inches, and they're parallel. Because this goes right here, and the valves go straight up into the guides here and push it on directly. No push rods, no difference in height, no nothing. So when you measure it, see it's the same 2 inches on center. You measure everything, which is the same as the airplane, which is nice. So now when you put this motor, this case on top of that, everything lines up. So that's really, really nice. The problem is that the height is 2 inches less than we need. The other problem is there's no room for a main bearing in here. See how small the bearing is? See, Sportster takes this size bearing here, and this big bearing over here is what this is. Except this is the earlier one, which is probably even bigger yet, but the 03 and up is the same as this bearing right here. This is the 9902, which is the bigger bearing. So the problem they have with these is they were so big the cams would hit them right here, the lobes, and you'd have to grind them out to make room for big high-lift cams. So Harley made the bearing smaller and put it on both sides. They got rid of the timken that's over there, right there, and they got rid of that problem of it hitting in there. This one's the early case, so you have the problem. So I'd like to keep the main bearing big because this is going to be a 200 plus cubic inch motor. So we need a lot of, it'd be nice to have a bearing that was bigger than this Sportster one over here, which is the same size as your 30s motor right here. Your 20 horse flathead motor versus your whatever Sportster motor will put out. They'll put out a good one will put out 100 horsepower, but they're pretty much in the 70s, and 80 horse isn't hard to get to. So the big difference in power level, but you're going from that to over 200 horsepower. If you figure a horse per inch, that's 200 inch motor, that's 200 horsepower. So you're going to be running 5 times the power through your motor, actually be 10 times more. You go from 20 horsepower to 200 horsepower. And probably the torque goes up almost as bad. So I'd rather use a bigger bearing here. So that means I'd use this twin cam. I also need to have an oil pump drive of some type. I have an oil pump. And when you run the Sportster motor here, the pump goes in here and comes off of the cam, off of the crank gear with a with a worm gear, and these things don't have any provision for doing that kind of stuff. They run a pump on the end of the snout. So to convert it, you'd have to take a big twin crank that has a big ass shaft coming out. You have to cut it down to this real small diameter right here, to this diameter here, slide a gear on it, and then you can drive it. Which really I didn't want to do. It makes it really weak. So what I'm thinking about is you take the Sportster case and you cut it right through here, and then this, take the race out. This aluminum right here would sit right on top of this aluminum right here, and that would raise your cams up, which would give you room to put the bigger bearing in. The next problem is you got to have a bigger drive gear system in order to keep your drive system the same. So it's half speed. So the gear that's on the cam has to be twice as big as the one on the pinion. So there's 3 sets of cam gears out there for Harley. You got the Sportster one, which is your smallest distance, and that distance is not very big. It's like 1 3/4 inches. Then you got an Evo motor, which is the same as one of these over here, which I don't have provisions to measure very easily, but they're more. Yeah, I can't get in there. Anyway, it's the next size up. There's one over here, but it's buried in here. I can't get to it. So, anyway, it's bigger. Anyway, this other one, the twin cam, it's even bigger yet. So if you go from your center bearing here to your center bearing up there, you're 2 3/4 inches. See, that's 3 inches sitting right there. So basically, it's an inch taller. Now, S&S makes the gear drive that comes off here with solid gears that would give you the gear drive. So basically, what I'm thinking about doing is you take a Sportster case, you cut this stuff all out right through here, you lay it right on top of this case right here, and this case is 3 inches plus deep versus that one, which is only less than 2 inches. You can actually sit it right on top of this case and bring it out flush. You can see how the main bearing's flush on a Sportster to your gear system. This one is not. See? And that distance that comes out would be bring your cams out, which would give you more room for your head bolts over here, because this all needs to come out to make room for the head bolts that are on your cylinder right here. Not head bolts, but cylinder base nuts. It's the other way over there. So that all that would move out. The other thing is this case is even deeper yet than that, so you can bring it out at probably a full inch. So it would not even sit on this, it'd probably sit on top of this, basically. So that's kind of the direction I was heading to going, but somehow I got to make a gear drive to drive off the crank to make this all happen. And somehow make room for the oil pump in there, which I'm not sure how that's going to happen just yet. Right now I don't have a twin cam crank here, they're all up in storage, so I'm not near storage, so not happening. I like the 45 case because it has the correct centerline dimension. These are vertical, they go straight up, and that's all the same as how the cylinders are done on this airplane motor. Okay, I went upstairs and grabbed a more junky 45 case. This cam cover's been all welded up, so that can be butchered. This case has all been had a rat in here eating on it, so it can be butchered also. I'm not going to use the main bearing, so I don't care about that part. So basically, when you line this all up, it was lined up until someone hit it. When you put this thing up on here and put it on center where your bore is at, the other one has studs on it. Anyway, it comes out over here and the lifters kind of line up a little bit. So right now it's a little off, but when you offset it like this to get the bigger bore, so you can't run it here, you got to move it over, then that brings your lifters in. Somebody keeps hitting these damn things and moving them, but there, I had them like this before. That's why I'm moving on me. See, the fins are the holding fixtures. See how that works? So basically, when you move this thing over to center it up off of this, your center of your case now is in far enough up that you will have some material to actually run the cylinder, even though this is a 2 3/4 bore cylinder and that's a 5 1/4 bore. It works. So the push rods will line up pretty evenly. And that would work, might make it work pretty good. Because that was the problem I had with all this. None of this stuff lines up when you come up. They're too close to the cylinder. You'd have to twist them, obviously. Making cams would be kind of hard. At least with a twin cam, you have to custom make the grind, which means they're custom made cams, so big bucks. The lobes are not in the same spot. You'd have to change the lobes. That's a whole custom billet cam. It'd be very expensive. With a 4-cam motor, you can actually use, you got 1 cam per valve, so push rod, so it's easy. You can take the cams, change them, weld them when you need them, and you're done. So you can just take a standard set of race cams and use those. So you get a $500 set of cams versus, $1,500, $2,000. Big difference in price. And you got a good selection of cams to choose from because sportster race motors are common.